Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology, and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss the 19 ECEB 301 Analog and Digital Communication subject under the topic Frequency Shift Keying. So, in this Unit 4, that is Digital Modulation Techniques, already I discussed the use of ASK and how ASK is generated and the various methods of detecting ASK and advantages, disadvantages and applications of ASK are already discussed. If you have any doubts regarding ASK, kindly watch this playlist. Now, in this YouTube video, I am going to discuss the topic of frequency shift keying. The name itself is told the frequency is shifted. So, as you know previously, this digital to analog conversion having three methods: ASK, FSK and PSK. Already ASK completed. Now I am going to discuss the FSK. A digital modulation techniques that allows data transmission by changing the frequency of the carrier wave according to the digital modulating signal is known as frequency shift keying, where here only the frequency alone is changed with respect to carrier, whereas amplitude and phase of the carrier will be not changed. This figure shows the frequency shift keying waveform representation. The first figure shows, that is 1001101 shows the digital bit stream or the data that must be transmitted. The second green color shows the high frequency carrier wave, and the third figure shows the low frequency carrier wave, and the final, that is fourth subdivision, shows the FSK modulated waveform. If you see the figure, if the data bit is 1, then FSK waveform will be converted into high frequency. If the bit is 0, then FSK will be converted into low frequency. So as like as in ASK, FSK also having some concept. That concept is, whenever the bit stream is 1, the bit will automatically change into highest frequency. Whenever the bit is 0, the FSK will automatically change into low frequency. These kind of techniques are applied in some kind of optical fiber communication methods. If B of t is equal to 1, then SH of t is equal to root 2 PS cos 2 pi f naught plus omega of t. This shows that whenever we transmit a bit of 1, the high bit will come. If B of t is equal to 0, then SL of t is equal to root 2 PS cos 2 pi f naught minus omega into t. This shows that whenever we have bit 0, then the phase shift is minus 180. Thus there is increase or decrease in frequency by omega. Let us use the following conversion table to combine the above two FSK equations. B of t is 1, then D of t is 1, then P high of t is 1, and PL of t is 0. When B of t is equal to 0, then D of t is minus 1, PH of t is equal to 0, then PL of t is plus 1. We can write equation, previous two equations combinedly as S of t is equal to root 2 PS cos 2 pi f naught t plus D of t into omega of t. Thus, when symbol 1 is to be transmitted, the carrier frequency will be f0 plus omega by 2 pi. If symbol 0 is to be transmitted, the carrier frequency will be f0 minus omega by 2 pi. That is, in general, whenever the bit 1 is come, the high frequency is f0 plus omega by 2 pi. Whenever the symbol 0 is transmitted, the low frequency should be f0 by omega by 2 pi. So this figure shows the block diagram of BFSK transmitter. As you see the figure, the input sequence will be the combination of ones and zeros. So whenever the data 1 will come, it goes to the upper level or higher level. Whenever the data 0 will come, it pass on to the lower level. So when you take 1, that is PH of t, it's given to the level shifter for incrementing the value. Then it is multiplied with the carrier of root 2 by TB cos 2 by FH of t. As like similar, when the data 0 is comes, it's given to the inverter, that is PL of t. PL of t is given to the level shifter, that is the output will be root 2 PS TB into PL of t. These both are multiplied by using a product modulator, which is indicated as a circle inside the cross symbol. Both these carriers multiplied are given to the summer, and the summer will deliver the addition of both higher, that is 1 symbol, and the lower 0 symbol, then we can get the BFSK signal. So in this YouTube video I discussed the various types of digital modulations and how FSK is different from ASK and the transmitter section of FSK. Now in the next video I am going to discuss the receiver part of BFSK. Thank you for watching my video.